Hello student, welcome you all by Shumit coaching class. Myself Samadhan Patil, and today we are going to start the first lesson of mathematics for class 9 CBSE board, and the unit is number system. Okay, so let us start the number system. Actually, you know the number system. In the previous standard you have seen about that. You have learned the concept of number system. So the different sets are there. Okay, that sets you have seen. So let us see them one by one. Now consider the number line. So everybody knows the number line. So as we know that number line is like this. Okay, see, if we have the 0 at the center, and positive numbers are there in the right hand side and negative numbers are there on the left hand side. Am I right? So these are the positive numbers. See here, we have the positive numbers in this side. Okay, so as we go alongside, so we get the positive numbers, and if you go in the left hand side, we get what? We get a negative numbers. Okay, so in this side, so these are the positive numbers, negative numbers. There are infinitely many positive numbers on the right hand side. There are infinitely many negative numbers on the left hand side. Okay, so also we have seen in the previous standard. Actually, we are recalling all that things that we have seen in previous standard. Okay, now there are infinitely many numbers in between these two. Okay, so many rational, irrational, whatever you know. Okay, so there is the, we have seen actually the representation of the rational number on the number line. Okay, that representation we know. Suppose if I want to represent 1 by 2 actually. Okay, so if I want to represent 1 by 2 on the number line, so that how I can represent that. So this is 1 by 2. So how we can represent this number on the number line? Okay, so because it is like this. See, 1 by 2 is less than 1 and greater than 0. Okay, so this 1 by 2 is less than, and so surely this is in between 0 to 1. Okay, so therefore it is here actually 1 by 2. Okay, so this is in between 0 to 1. Now, so the next is suppose if I want to show this number 5 by 2 minus 5 by 2, so exactly it is in between what? Minus 2 and minus 3. Yes, so in this way we can represent the rational number. So there are some specific rule to represent the rational number on the number line. So that rule already we have discussed. I'm not going in detail about that. Okay, because we have to cover the next important concept regarding this. Okay, so just we are revising these concepts that you know. Okay, now, so just imagine if you start. Okay, here we just imagine if you start from 0 here. Okay, if you start from 0 and go on walking along this number line, what you get? So if you start walking from 0 and go on walking along the number line in the positive direction or in the negative direction. Suppose if we start from 0 and go in the positive direction means along the positive numbers, what do we get? So as far as you can walk. Okay, so as far as your eyes can see, so you just find numbers, numbers and numbers. Okay, there are numbers, numbers and numbers only. Okay, so suppose if we start walking from here and we just go in this direction, what I get? Only numbers, numbers and numbers. There is no end. There are infinitely many numbers, and we are starting from 1 0 here. So therefore we get the positive set of numbers, that is 1 2 3 4 and so on. Okay, so in this way what I get? So this is 1 2 3 4 5 6 7 and so on. We just go on here. So what I get here? We get a set of natural number. Okay, so now suppose you start walking along the number line and collecting some of the number, get a bag ready to store them. Okay, suppose if we take the bag and we are going to ready to store them in the bag. Okay, so what I get here? So we get a all set of natural numbers like this. Okay, that bags contains all set of natural number. Why? Because we are collecting them from 1 2 3 4 up to 5 so on. Okay, we get the numbers and numbers only, and that all set of numbers are called as what? Natural number. We denote it by, so you might begin with picking only natural number like 1 2 3 and so on. You know that this list goes on forever. Okay, there is no end for this list. And what you say, this list, this is what? Set of natural number. Many natural number, we denote this collection by capital N. Am I right? So this is the notation. This, we denote the set of natural number by this set capital N. Okay, now so let us come back. Okay, so and now pick up the 0. What I get? Now return, turn and walk all the way back, pick up the 0 and put it into your bag. So if we add 0 in this bag, what I get? Yes, it is set of whole number. So if we put 0 in this bag, what I get? So if we put 0 in this bag, we get a set of whole number, and it is denoted by what? W. Okay, so this is what? This is the set of whole numbers. So from 1 2 3 4 5 we get what? Set of natural number. So if we add 0 for 0 in this bag, so see here, I just put the 0 in this bag, so what I get? Set of whole numbers. Okay, so set of whole numbers is nothing but what? We just add 0 in the set of natural number. Okay, so 0 1 2 3 4 are the set of natural set of whole numbers. Okay, so once again just return back. Okay, so in the left side of the real line, okay, see if we go on in this side. Okay, now stretching in front of you are many negative integers. What you find? There are many negative integers, like, so see, if you go in this direction, you can find what? If you go in this direction, so you can find many positive numbers. If you go alongside, so in this direction, you can find what? Many negative integers, and put them all into your bag. Okay, so if you put again all that negative integers in your bag, so see, I have put all that negative numbers in my bag, so what I get here? So we get the set of all positive, 0 is there also, and set of all negative numbers. Okay, and it is the collection of all integers, and we, it is denoted by what? Z. So this is the symbol Z, so that Z is denoted what? Denotes what? Set of integers. Are you getting this? Okay, so one by one we just introduce the set. Okay, so how that set we get? Okay, so that set are one by one, that there are the, there is the invention. Okay, so that is the that story I will explain you in another lecture. Okay, about how we introduce the sets. Okay, one by one, but here we just learn, we just revise them that we have learned in the previous standard. Okay, so I have told you that story about how the invention of integers. Okay, so we just talk about that later. Okay, in the another lecture. So it is denoted by Z. Okay, so this is the set of integers. Now, so we have seen what? Set of natural number, we have seen set of whole number, and now this is another set, it is what? Okay, are there some numbers still left on the line? Okay, so are you sure all the numbers we have taken in the bag? Of course, no, there are some number. There are numbers like this. See, 1 by 2, 3 by 4, or even minus negative numbers are there also. We can't take them in our bag. Okay, so see, take them in our bag. See, it's minus 6 by 7, 2005 upon 2006. All that number we have taken. Root 19 that we have taken also. Minus 12 by 13 is there. 9 by 14 is there. So we are collecting all those number which we haven't taken previously. Am I right? So in the previous bag we don't have that numbers like this. Now we are adding these all numbers in my bag. Okay, and now these numbers are what? We put all, if we put all into the bag, we get a new collection of set called as what? A rational number. So these are all are These all are what? Rational number. Actually we have the separate unit in the 8th standard regarding this rational number. Okay, so we have seen about rational number, their addition, their subtraction, their multiplication, okay, representation of rational number on the number line. All things actually we have discussed in the previous standard about the rational number. Okay, so we are just revising that here. So all these type of numbers are what? Rational number. Okay, now that is denoted by what? Q. Okay, so rational comes from the word ratio and Q comes from the word quotient, and therefore these are called as a rational numbers. Okay, and it is denoted by what? Q. What type of number it is? So the number, it is of the form what? So it is a number are said to be a rational number if it can be written in the form of P upon Q. Okay, so this is P upon Q, where P is what? Where P and Q are not. So where P and Q are an integers and Q be never 0. This is very important. Okay, so why Q is never 0 here? Why Q? See here, suppose if 1 by 2 is what? 1 by 2 is a rational number. Okay, suppose if sorry, P, suppose if I take 1 upon 0. Okay, suppose if I take 1 upon 0, it is not defined. Actually it is not defined. Okay, so we cannot define this number, so it is not defined. So therefore what? This is not a number even. Okay, so this is infinite number. So actually it is not defined, so therefore Q never be 0. This is very important. So you can take P0, you can take P0 because we can write 0 upon 2 as a rational number. So this is also a rational number. 0 upon 2 is what? 0. 0 upon anything is 0. So therefore what? This is an rational number. This is a rational number. So 0 is a rational number. Okay, but 1 upon 0 is not. This is not defined. Okay, so this is not an rational number. Are you getting this? So let us see the T diagram that we know. Okay, so first is a real number set. So what is real number set? It contains all the sets. Okay, so it is rational, irrational. Okay, so what is there in this real number set? So a rational number set is there. Okay, also irrational number set is there. Okay, that we have seen the rational numbers and how that irrational numbers also. Okay, now so in the rational number set there are two types of set. Okay, integers and fraction. Okay, so rational number is of the form P upon Q. Okay, uh, right now so it is of the form P upon Q, where Q is never 0. We have seen this. Okay, so this is of the form P upon Q. In the previous standard also we have discussed about this. Okay, so this is of the form P upon Q. This is rational number. Okay, now these rational numbers contain integers and fraction. So integers are from minus infinity to, okay, so it is plus infinity. Okay, so this is from minus infinity to plus infinity. So this is the set of rational. Okay, sorry, set of integers. So and fraction. So what is there in the set of rational integer? So in the set of integers, so we get a whole number. Okay, whole number from 0 1 2 3 4 5 so on up to infinity. Okay, again what is there in the whole number set? So in the whole number set there is natural, there are natural numbers. Okay, whole number is the combination of 0 and, so it is a combination of 0 and natural numbers. Natural numbers are what? 1 2 3 4 5. It start from, they actually start from 0, sorry, 1 2 3 4 5, and if we add 0 in between them, so we get a whole number. Okay, so this is the addition of these two, so we just add them, 0 and natural number, will get the whole number set. Okay, and then after that negative integers are there, so we have seen in detail about that. Okay, so if we see the back, okay, we get the on the actually on the left hand side of the real line, so we get all negative integers. Okay, so again fraction, so there are two types of fraction, positive and negative. Okay, so it is again of the form p upon q. Now irrational again of the form p they are either positive or negative. Okay, so we have seen all these type of numbers. Okay, I just explain you. So from this T diagram, so you can understand the set of numbers. Okay, so a real number, then rational, irrational, then integers, fraction. So irrational contain two, integers, fraction, then whole number. So whole numbers contain zero and natural numbers, and there are again negative integers in the integers and irrational, so they are positive and negative, and fractions are in the rational also. They are of the form positive or negative. Okay, so let us see some examples. Is example, are you following, are the following statements true or false? Give the reason for your answer also. Okay, so see the statements, every whole number is a rational number, is it true? uh, every whole number is a natural number, it is false actually. Why? Because see, 0 is there in the whole number, 0 belongs to what? W, and 0 is not natural number. Yes, it is false, that we will discuss. Okay, first is false. Why? Because 0 is a whole number but not a natural number. Second is every integer is a rational number, every integer is a rational number. Integer, yes, it is true, because every integer we can write in the form of rational number. So 1 can be written as 1 upon 1, 2 upon 2, minus 2 can be written as minus 4 upon 2. Okay, so that are what? Because every integer m can be expressed in the form of m upon m 1, and so it is rational number. Every rational number is an integer. It is false, because 3 by 5 is not an integer. 3 by 5 is a rational number, it is not an integer. Now the example number 2 is find 5 rational number between 1 and 2. Okay, this is very simplest example that we have seen in the previous standard. Okay, so the see how many, and there are actually infinitely many rational between two rational numbers, two numbers. Okay, so we have seen that statement, but we only have to find 5 rational numbers between 1 and 2. So how we get that numbers? Okay, so therefore we want the 5 numbers, then we can write 1 and 2 as a rational. Okay, so we know that by similarity of rational number, so we can write any rational number so that the values of two rational number may be same. So we want the 5 rational numbers, so their denominator become 5 plus 1. Okay, so if we want the 6 rational numbers, there this is the one of the method. Okay, we can find the rational with the help of another method also. We just discuss the simplest method here. So what is the procedure? So if we want 5 numbers, then take the denominator as 5 plus 1. If you want 6 rational numbers, then they take denominator as 6 plus 1. Okay, so that we get what? We get a denominator as 7. Okay, so here we want the rational 5 rational numbers in between 1 and 2, so we take the denominator as 5 plus 1, and we can write 1 and 2 in the form of the rational whose denominator is 5 plus 1. So it is like this. See, 1 can be written as 6 upon 6. So 1 can be written as 6 upon 6. So this 6 is nothing but 5 plus 1. Am I right? So this 6 is nothing but 5 plus 1. And also this 6 is nothing but 5 plus 1. And now 6 is 1 is 6 upon 6 and 2 is 12 upon 6. Okay, are the rational numbers. Okay, so 1 can be written as a 6 upon 6 and 2 can be written as also 12 upon 6, and therefore these are the rational between these two. See here. Okay, so these are the rational numbers between what? Between these two numbers 1 and 2. So 7 by 6, 8 by 6. See, for 1 is 6 by 6, and the next number is 7 by 6, next number is 8 by 6, next number is 9 by 6, 10 by 6, 11 by 6, and then after 12 by 6. So are the rational number between 1 and 2. Okay, so therefore these are the rational number between 6 by 6 and 12 by 6. And what is 6 by 6? 1. And what is 12 by 6? 2. You know this method, so we just revise that. Okay, now this is one more important note. There are infinitely many rational number between any two given rational numbers. Okay, we can find infinitely many rational between any two rational numbers. Okay, let us see the exercise 1.1. Okay, so the first example is 0 is a rational number. Can you write it in the form of P upon Q, where P and Q are integers and Q is never 0. See, Q is never 0. We have seen that if Q is 0, we cannot define that number. Okay, so we just have to check whether the 0 is rational or not. Also, I have told you about this. 0 is a rational number. Okay, why? Because yes, this is 0 is a rational number, because 0 can be written as 0 0.6, 0 0.1, 0 minus 1 by 3. Okay, so Q is never 0. See, this is Q, 6, 1, minus 3, these are Q. P we can take 0, no problem, but Q is never 0. We haven't take 0 here. Q 0. See, these are the integers. Okay, so therefore this 0 can be written in this form. Therefore 0 is what? 0 is a rational number. So you can take any integer in the denominator. You can take any integer in the denominator instead of 6, 1 and 3. Okay, so that will be what? That will be 0. So if we take 0 in the numerator and any integer in the denominator, that will be what? 0. And we can write that 0 in the form of P upon Q. Therefore 0 is a rational number. This is true. Okay, next is find 6 rational numbers between 3 and 4. How to find 6 rational numbers between 3 and 4? This is again simple, that we know. We have seen that. See here, what we want 6 rational numbers between 3 and 4. So what should be our denominator? Our denominator should be 6 plus 1. Okay, it is equal to what? 7. Our denominator should be what? 7. Okay, see, there can be infinitely many rational numbers between the number 3 and 4. Okay, so we have seen this statement, but few of them can be taken as. So we want 6 rational numbers, and therefore we can take 3 and 4 as a rational number with the denominator 6 plus 1, as I told you. Okay, so now see, 3 can be written as 21 upon 6 plus 1. 6 plus 1 is nothing but 7. Okay, and 4 can be written as 28 upon 6 plus 1. Okay, so here, so this is 21 upon 7 and 4 is nothing but 28 upon 7, and between in these two we get these rational numbers, 6 rational number: 22 upon 7, 23 upon 7, 4 upon 7, 25 upon 7, 26 upon 7, 27 upon 7. So make the denominator as equal, so we get the rational number between them, isn't it? So this is one more simplest example. Okay, now next is somewhat different. Find the 5 rational number between 3 by 5 and 4 by 5. So we use the equality of rational number here. So two rational numbers. So this P upon Q is not unique representation of any rational number. So there are some another rational number that can be written in this form 3 by 5. Their values is 3 by 5. That we use that concept here. Okay, so as we know that rational numbers do not have unique representation. So see, 3 by 5 can be written as 30 by 50, isn't it? So 30 by 50 is nothing but 3 by 5, and 4 by 5 also can be written as 40 by 50. Am I right? Okay, and therefore 5 rational number between 30 by 50 and 40 by 50 are what? 31 by 50, because their denominator, see, the rational number whose denominator are same, we can write any number of rational number between them. So 30 by 50, 40 by 50. So what? 31 by 50, 32 by 50, 33 by 50, 34 by 50, 35 by 50. Next is 36 by 50, 37 by 50. We can write that also. Okay, so we only want five numbers, so therefore we have written these five numbers here. Okay, so these are the five rational numbers that we want in between 3 by 5 and 4 by 5, means 30 by 50 and 40 by 50. Okay, so make the denominator same so that you can find out what number of rational numbers between denominator. Because see here, these are a rational numbers, these are not integers. That's why we have to use this trick here. Okay, in the previous example, so we want five rational numbers. What we do, we just make their denominator as 5 plus 1. Okay, now this is homework, so try to solve this example. This is very simple. So state whether the given statements are true or false. Give the reason for your answer also. Every natural number is whole number, so first every integer is a whole number, every rational number is a whole number. Okay, so we just discuss that. You just solve this example at home. This is also simplest example, and then after that we will see the next concept. It is irrational number actually in the next lecture. It is very important topic, and in that topic we will discuss about the addition, their subtraction, their representation on the number line, and etc. Okay, so we just stop here. Thank you.